Now that we know what polynomials are, let's actually do some work with them. So in this video, I want to go through how to add and subtract polynomials. And the nice thing here with adding and subtracting polynomials is there actually is nothing new. We're just going to basically combine like terms. Okay. All right, hang on, let's get this focus fixed. There we go. So for our first example, we have two polynomials here. So remember, for your polynomial, we're just looking at something that has exponents that are specifically whole numbers. That's the biggest piece here. And nothing weird going on. So we're not dividing by any variables as well. I will say that you actually can multiply variables together. That would be okay. Again, we tend to do that more in advanced classes, but you could actually have something like x times y. That would be fine, but no dividing by variables, and our exponents are specifically whole numbers here. So here, each of my polynomials happens to have two terms. So just as a quick review, those are called binomials. Bi means two, but it really doesn't matter what kind of polynomial it is. We're just going to add it the same way. So these parentheses here actually really not doing anything either. They're just trying to show us our two polynomials. And because we have a plus sign in the middle, the addition sign is not going to change anything. So what I can do when I'm adding something is just rewrite it if I want to. And then, like I said, we're just going to combine like terms. So I see a 3x piece and a 5x piece. Those are like terms. And then I also see a +1 and a -4, which are also like terms. Now for that -4, if you don't really like those subtraction signs, remember you can always change it to adding a negative, and that will help you with your computations here. So 3x and +5x is 8x. +1 plus -4 is the same thing as -3. And that's it. We added those two polynomials. There we go. All right, so here's another example. So here I have a binomial and a trinomial. So again, it doesn't matter, they're both polynomials, but I have two terms here and three terms. So just to kind of review some of those definitions. And because we're adding, there's really nothing to do. I'm not multiplying by anything outside the parentheses. I just have a plain old addition sign, which doesn't affect the sign at all. So I'm just going to rewrite this. The parentheses are there just to kind of show our two different polynomials. And I'm going to go ahead and combine like terms. So I see a -5x squared, which is a negative, and a +2x squared. So -5 and +2, when we add those together, we have -3. So I have -3x squared. And also remember, when we're combining like terms, the variable doesn't change, right? When we're adding or subtracting, we're just keeping that variable with it. And then let's see, I have a +10x and a -3x. Again, if you are stuck on those subtraction signs, you can always change it to adding a negative. You really want to think about subtraction and negatives as pretty much interchangeable. +10 and -3 is going to be a +7x. And then here, I am going to note that I do have this +4 still hanging around, but I don't have anything to combine it with. So I'm just going to bring it straight down. I have no more like terms, so we are done. That is our final answer. And let's do one more. So let's find the sum of negative y squared plus 4y plus 1.5 and 6y plus 7 3/10. So what we can do is also just write it down the same way. This is kind of my preferred way to do it. Some students like to do it vertically, so I will show you how to do that in this video too if you want to see it vertically. So the way I like to do it is I'm just going to rewrite this and just kind of put them next to each other. Again, if you're adding here, it's not really going to matter to put those parentheses in. Addition doesn't change when we have parentheses, it doesn't affect anything. So I can just add those two polynomials right next to each other and combine like terms. So I see a y squared piece, but I don't see it anywhere else. So I'm just going to bring that one down. I tend to like to go in order of our powers. That tends to be pretty common. You don't have to write them in order of highest to lowest for powers. That's called descending powers, but we often do write them that way in order. So I'm just going to go right down the line. Here, 4 and 6 is 10, so I have 10y. And then let's use a different color here. I have 1.5 and 7 3/10. Now you can use a calculator here, or if you want to just do a little work off to the side, you can go ahead and do that. We have 8.8. And that's it here. So I'm just going to make a little note here. That term descending powers. So powers refer to exponents. If you ever hear powers, we tend to use those words interchangeably. And descending means decreasing. So like I said, you don't have to write them in this way, but you typically do see examples written like that. Sometimes it'll be written in ascending, so going up and increasing powers, but more often than not, you tend to see things written as decreasing powers, just to stay a little bit more organized. Now, another way you can do it is to line everything up vertically. So I'm just going to do this one time. I actually just prefer to rewrite things and combine like terms using colors. I find it easier, but some students like to line everything up, and you can do that too. So if you're going to line everything up vertically, you just want to make sure that you also line up your like terms at the same time. So for my first polynomial, I'm just putting it up top, and then my second polynomial, I'm going to put it down bottom. So I have a positive 6y and then plus 7.3, and we're going to go ahead and add these. And then I just kind of go down the columns of my like terms. So you still have to recognize your like terms here and organize it. You also want to watch out for negatives, make sure you don't miss anything like that. And then you're just going to go ahead and add them up. So here is 8.8, bring down, they're both positive, so I'm just going to bring down the plus sign. Here again, these are both positive, so 4 plus 6 is going to be positive 10. And then here I just have a negative y squared. So if you prefer to use a vertical method here, you can go ahead and do that, whatever is easier for you. But in both cases, we're just really combining those like terms. Now for subtracting polynomials, it is almost exactly the same, but we have one change to do first. So because you have that subtraction sign in the middle, you actually do have to distribute that subtraction sign because it does affect things, right? Adding doesn't change any signs if I have addition sign there, but subtraction does, right? Because subtraction is the same thing as changing to a negative. So we're going to, first of all, distribute the subtraction sign through the second set of parentheses, and then we will combine like terms. So here I have an example. I'm subtracting two trinomials. Each of them have three terms. So here's what you have to watch out for, and a lot of students make this mistake. They'll distribute the minus sign to the first term, but not everything else. So you need to make sure you use that minus sign on every single term. So what's going to happen is it's going to change all signs over that are inside the parentheses there. So my first part stays the same, and then what's going to happen is this positive 3 is going to become a negative 3x squared. The minus is going to become a positive or a plus 7x. And then that plus sign is going to become a minus sign on the 5. So we're going to distribute that negative through, and it's going to change every sign over on that second polynomial. And then once that's done, now I can just go ahead and start and just combine my like terms. So I see a 5x squared and a negative 3x squared. So it's the same thing as adding a negative. So I'm going to have 2x squared. I see a positive 2x and a positive 7x. So 2 plus 7 is 9. So I have 9x. And I see a minus 1 and a minus 5. So that's the same thing as a negative 1 and a negative 5, which is going to be negative 6. So you could write it like this, or subtraction signs and adding a negative are the same thing. So I can rewrite it like that. Let's do another example. There we go. So we're going to subtract this trinomial from this binomial. So 3 terms and 2 terms. Now remember that word from reverses the order. From and than. So if I say something like less than, right, that's going to reverse the order. So what's going to happen, I'm going to rewrite this. I'm going to set it up. The second one goes first because of that word from, and then the first one goes second here. Now again, I'm going to make sure that because I have a minus sign there, it's going to change over all signs. So I have 2z squared plus 5. Now here, this negative is going to cancel, become a positive, so plus 6z squared. This plus sign is going to become a minus 4z, and this minus sign will become a plus 1. Now everything's changed over. I can just go in and combine like terms. So I see a 2z squared and a positive 6z squared, which would be 8. Let's see, I have a minus 4z just kind of hanging by itself, so I'm just going to bring that straight down. And then I have a plus 5 and a plus 1, which is positive 6. And remember, once you're adding and subtracting, the variable part just stays exactly the same. So we don't have to worry about changing anything over there. Now, here I have 2 examples of subtraction that I did. And again, you could have fractions and decimals out front, but we're just going to use the same techniques we already have. So if you have any decimals, if you have fractions, you're just going to combine those with your polynomial techniques here. Now, you can also do this vertically. So let me do one more example of subtraction here. So you can do these vertically if you like, although I do find, again, it gets a little bit confusing with all those sign changes. So I would still change everything over first and then write it vertically after that. So for instance, we have 1/2 x squared plus x minus 1. I don't have any keywords like from or than, so it's just straight subtraction here. And you want to remember that this is going to change all those signs over. So if I'm setting anything up vertically as well, which again is not necessarily my preferred way, but some people like it, I would actually change my signs over first as a personal preference. I find it's less likely to make mistakes. If you try to set up subtraction vertically with polynomials, a lot of times students forget which signs they've switched, which signs they haven't switched. It's a little bit messy. So I would just change your signs over first if you want to. And then you could always set this up vertically if you needed to. So here's my first polynomial, right? And then my second polynomial is negative 3/4 x squared minus 2x minus 4. And then now we've already changed things over, so you're just adding them together. So if you're doing the vertical setup, once you've changed everything over, then you can just add vertically. You don't have to worry about it. So here you have a -1 and a -4, which is -5. You have a +1 and a -2, so I would have a -1x. Now here, you may have to do some work off to the side. So remember, for fractions, you do need to have common denominators. So I could use a denominator of 4 here, and I would multiply this first fraction by 2/2. So I'd have -1/4 for my fraction. So this is fine, or if you want to clean it up a little bit, we could also write this as -x minus 5. So I don't have to write the 1 in there, and I could change adding a negative to just subtraction, and that's fine too. So again, if you want to do it vertically, there's different ways to do it vertically, but I do suggest changing your signs over first. I think it's easier than trying to do it within a vertical setup. I think it gets a little bit confusing. But if you don't want to do it vertically, you don't have to. So for me, I just like to just go through and combine my like terms. So I see like terms there, and we did the work off to the side, so we get that first part. I see like terms here and here, so there's that 1x. And then I see like terms here and here, so there's that -5. Now, just like before, you could also evaluate polynomials. So find So a little side note here, sorry, I'll move that up for you guys, is you can also evaluate polynomials. So we've done evaluating many, many times so far. And we can just evaluate like we always have in the past. So if you already learned how to evaluate in any other example, in any class, it just works the same way. So evaluate just means to plug in, right? So we're going to plug in the given value and simplify. Okay, so evaluate no matter which course you're in pretty much, or what level you're at, it just means the same thing. It means to take the value given and plug it into the expression. So here, anytime I see a t, I'm going to go ahead and replace it with -1. So let's go ahead and do that. I do like to use parentheses when I evaluate. This helps me to stay a little bit more organized. And then you do want to follow the order of operations. So I do want to do the exponent here first. And just remember that for cubing, it means to do this out 3 times. -1 times -1 is +1 times -1 again is -1 overall. So this becomes 3 times -1 plus -1 minus 4. 3 times -1 is -3. Okay. I'm going to switch the subtraction into adding a negative as well. And then now I can just go ahead and finish my problem by adding all my values. So -3 plus -1 is -4, and -4 plus -4 is -8. So techniques that you have already know with combining like terms, with distributing negatives throughout the parentheses, for instance, with evaluating, they all still work the same way for polynomials. So really, the beginning parts of polynomials are nothing new. We're using new terminology, but the techniques are all things that you already know. All right, let's do one example here of an application. Okay. So let's say an object is dropped from the top of a 200-foot building. Its height at, so this should just be a 200-foot building. Its height at time t seconds is given by the polynomial -16t squared plus 200. Find the height of the object after 1 second and after 2 seconds. Now, this is actually a pretty standard formula, and it does assume that there is no real wind that you have to worry about here. So if you drop an object off of a building or down a stairwell or anything like that, there is a general formula that we use, and this is it here. So it's -16t squared plus whatever that initial starting height is. This is a great formula. There's a ton of applications with things like dropped objects and thrown objects. So if you think about hitting a baseball, things like that, these are all polynomial examples. So this is a pretty common one. I will say though, we are assuming that there's no big wind here going on. So if you had big gusts of wind, this could change the time it takes to fall. And of course that the object is, you know, not super light, like a feather that would not normally fall at a normal speed, right? But let's say a coin or something like that. So our polynomial here is -16t squared plus 200. And we have two questions. We're going to find out the height of the object after 1 second and after 2 seconds. So like I said, here's your building. And we're going to drop, I don't know what the object is, but we're going to drop a little object off the building. And it's going to obviously fall to the ground, right? So after t equals 1 second, okay, so it starts up here at 200 feet. We want to know how high off the ground is the object. So I go ahead and plug it in. So I plug in 1 here for t. Now 1 squared is just 1, right? 1 times 1 is 1, and -16 times 1 is just -16. So when I add -16 and 200 together, I get 184 feet. So after about 1 second, maybe like right here, the object is at 184 feet. Let's try 2 seconds. So now I'm going to go ahead and plug in 2. So exponents first, 2 squared is 2 times 2, which is 4, right? So now I'm looking at -16 times 4. So I have a positive times a negative, it's going to stay negative. So I have negative 64 plus 200 now. Now, of course, you could take out your calculator here, but it doesn't hurt to do a little bit of work off to the side now and then. And I have 136 feet. So after 2 seconds, now we're still a little bit above the halfway mark. We're at 136 feet, and so on. So we can go ahead and just plug in different values and see how long it takes for this object to hit ground level, basically, right? So you think about it, ground level here, that would be at 0 feet. So after 1 second, we're still 184 feet in the air. After 2 seconds, we're 136 feet. And we could keep plugging in values to see how long it takes us to get to that 0 foot mark. Now, an interesting thing to think about here is, you know, I could plug in anything I want, but you want it to make sense, right? So I know I could evaluate this for t equals, -5, but -5 seconds doesn't make sense for this problem. So when we're doing real world problems and we're evaluating or we're adding or subtracting or whatever we're doing, we do want to think about what's reasonable here, right? So looking at 1 second, 2 seconds, and so on, these are all reasonable values to plug in, whereas I wouldn't want to plug in a negative value. That wouldn't make sense to have negative time. And same thing here. So I could plug in t equals 100, but I'm going to be in a negative answer. So I'm going to be underground. Again, that doesn't make sense either. So when we're doing real world problems, you just want to think too about, what values make sense to plug in. So here, some, I guess, lower positive values would make sense, right? Up until a certain point.